Hi there, welcome to the Snowflake Developer YouTube channel. My name's Caleb Bechtold, and I'm one of our principal architects for AI and machine learning here at Snowflake. If you're here watching this video, you've undoubtedly heard that Snowpark Container Services is officially in public preview in limited AWS regions. And so today I'm going to walk through start to finish our brand new Intro to Snowpark Container Services Quick Start, where we'll show you what it means to work in Snowpark Container Services, how it works, how you build and deploy services, and then interact with those as an end user. Everything I'm going to show today is accessible to you via our Quick Starts page, and we have links to everything in the description below, so feel free to follow along and pause as we go through things, or watch this and then go through the full Quick Start in your own time. But either way, you'll have the opportunity to follow along now that this feature is accessible to a number of our AWS regions. With that, let's go ahead and jump in and get started. As I mentioned, everything we're going to walk through today is on Snowflake's Quick Starts page, which is quickstarts.snowflake.com. You can go there to get started. We'll post the links, of course, to everything in the description. But if you go to the Quick Starts page and you want to find the exact Quick Start we're going to walk through, you can just type in container in the search bar, and you'll see Intro to Snowpark Container Services here listed below. And that's one we're gonna walk through. So we'll go ahead and click start there. Now, one thing I'll mention here, this says 100 minutes remaining. I promise this video is not going to be 100 minutes long, though. That timer has a lot of built-in time for, container build times and things like that just take time to run, but you won't actually really be doing anything during those moments. So we'll get through it much quicker than that during this video here. First of all, what is Snowpark Container Services? What are we actually going to be, building and using today with this new feature? So Snowpark Container Services is Snowflake's brand new compute runtime as part of the Snowpark family. Includes things like Snowpark Java, Snowpark Python, and now Snowpark Container Services, which lets you run arbitrary containerized applications inside of the Snowflake boundary, inside of your Snowflake account on managed Snowflake infrastructure, allowing support for CPU and GPU-based workloads where you can develop applications or GPU-accelerated machine learning models or host large language models and GenAI capabilities, all that sort of stuff. In concept, anything that you can run as a container, you can run inside of Snowpark Container Services. And so this quick start basically walks through getting started with two basic concepts within container services. And those are specifically the services and then functions that support Snowpark Container Services. Specifically, we're going to go through kind of the full development to deployment cycle here. So everything from building a base container image in our local environment, pushing those resources up to Snowflake, and then configuring services to utilize those. That's going to be the basic flow that we'll walk through. We're going to build two particular services. We'll build a long-running service with a user interface. Specifically, we'll be hosting Jupyter Notebooks as a hosted service inside of Snowpark Container Services. We're going to show you how you can use volume mounting to persist all the changes to your notebooks in your account and all that sort of stuff. We'll go into all those details once we get to that part. And then we'll also deploy a service function that allows us to do some basic custom calculations. So those will be the two things that we'll walk through. To do that, we're going to follow this general flow, which is configure everything we need in our Snowflake account, set up the Snowflake environment, build the corresponding images for those different services, configure our spec YAMLs. Spec YAMLs are essentially configuration files that define how a service works, what images should be used, what are the different parameters, environment variables, etc. that are configured. You can think of it almost like a Docker Compose YAML or a Kubernetes spec YAML, I think is pretty similar also. But we'll create those YAMLs, we'll look at those in more detail, we'll push those up to Snowflake, and then we'll ultimately create a compute pool and corresponding services associated with these two tasks. So that's going to be the flow, start to finish. Everything, as I mentioned before, is here in the Quick Start Intro to Snowpark Container Services, which we'll link below. So feel free to follow along as we go through this and pause to run the different steps, or maybe just watch the video and then try it yourself later on. So what are some of the prerequisites? So we'll go through, again, mechanics of how container services work, how we deploy these different services, etc. But what are you going to need to be able to do that? First thing is we're going to need Docker Desktop to be installed. I've already got mine installed. You can see it's running over here. we're going to need at least some sort of base Python environment. The reason for that is that we're going to be configuring a virtual environment in the third step here of the quick start. Optionally, you'll need Git, or at least you'll need to download our GitHub repo that's linked here in the quick start. So that GitHub repo has all of the source scripts and then base code and et cetera that we're going to need to build our services and push them. So you want to make sure you go ahead and clone that or download it. Again, you can of course clone it using git clone, but also just download the zip to your local machine if you want. You can put it wherever you need. I generally like to put things in a dev folder in my file system to find it easily, but go ahead and download that Git repository using either a git clone or download it as a zip, however you need. I'm going to be showing sort of the build processes. We're going to be looking at code inside of VS Code. So if you want, you can download VS Code. It's got some handy extensions for working with Docker and Python, as well as Snowflake, that you can install and use. I'll show you some of that as we go through it, but really you just need an IDE, whatever your preferred one is. And then the last things are going to be, you're going to need a non-trial Snowflake account in one of our supported AWS regions. So as of January 16th, when I'm recording this, that includes the London and Mumbai AWS regions for public preview, and it has to be a non-trial Snowflake account as well to use Snowpark Container Services. I'm going to be using a demo account in our London region. This page here, if we open that up, contains a current reference of available regions. So right now, again, we have AWS Europe London, AWS Asia Pacific Mumbai. We do have container services coming shortly to US West and a number of other regions as well. And importantly, you're going to need the account admin role, or you're going to need to work with your account admin to perform some initial account setup. So everything we do in this lab is going to be using this container user role, but we need to create that role up front and grant it to different users. So that's going to be something you'll need. If you don't have account admin, work with your Snowflake admin to do some of that, those initial setup steps. To create this role. And then from there, if you have that role, you'll be able to build and do everything else we need from then on. And again, so just to recap before we dive in, we're going to build a hosted Jupyter Notebook service that's running inside of Snowpark Container Services that'll have a basic notebook, and we'll show how to make changes and persist those changes and everything. We're going to build a Python REST API that does some basic transformations. We'll use temperature, Fahrenheit to Celsius conversion as like a simple example there, but really it's just going to be a generic Python REST API. And then we'll create a Snowflake service function to leverage that REST API. And we'll be able to leverage that service function from inside of our Jupyter Notebook servers too. So that's what we're going to be building. Go ahead and make sure that you have all those prerequisites installed. And then we'll get going on configuring our Snowflake environment. As I mentioned, we're going to be creating a container user role, which is going to have all the privileges that we need to be able to create compute pools, services, push our YAML files, all that kind of stuff. To do that, we have a script, which is in our source code repo here. So I've already cloned that source code repo to my local machine here, and I've got it open inside of VS Code. So this 00setup.sql script, which is part of that Git repository, has all of the commands that we need to run to configure our initial Snowflake account. So you're going to create, again, a new role. We're going to grant some privileges to that role, and then we're going to grant that role to another role or to a particular user. Then we're going to create some objects, database, warehouse, some stages, all that kind of stuff. You can go about running these steps in two different ways. One, if you have the Snowflake extension within VS Code, you can obviously connect to your demo account, your dev account, and run these directly in VS Code. But of course, if you don't use VS Code or you want to be working in Snowsite directly, we can do exactly that. So I'm logged into my particular Snowflake account that I'm going to be using for this walkthrough, and I've already uploaded all the various SQL scripts that we need into that account. So I have my 00setup .sql scripts that I've uploaded here. And I'm just going to go ahead and run all of these different steps. So as this runs, maybe I'll talk through a little bit about some of the steps that are going here. So as I mentioned before, we're going to create this new role, container user role, where we have the ability to specifically, in the case of Snowpark Container Services, create compute pools, as well as create service endpoints associated with those services. The reason for that is that we're creating a hosted Jupyter notebook. We want to expose that notebook, that application via a public endpoint that someone can then log into to be able to access it and run it. So we're going to create that role, give those initial privileges to the role. In this case, I'm going to grant that role to my account admin role as well, since I'm the admin of this account. But you could, of course, grant this role to an individual user or a different role as part of it. Next thing I'm going to do is create a hands-on lab database, which is going to be this container HOLDB. This is where we're going to push all of our resources, create our services, etc. I'm also going to create an initial warehouse that's just an extra small warehouse, just in case I need to run any actual queries, things like that. We'll see that later on when we create our service function and use Snowpark to interact with it. We'll need a warehouse where some of the queries are running and things like that. The other things that I'm going to create here are two specific stages. One is the specs stage and one is the volume stage. These stages serve two purposes. The spec stage is where I'm going to create and upload my spec YAMLs. So if you remember in the initial overview, when we talked about the development to deployment cycle, part of how you configure a service is the spec YAML, essentially these config files. And to be able to configure those or create services using them, we need to have a stage, which is ultimately where we're going to push those spec YAML files to. We then reference that stage and the files within that stage within a create or replace, create service type statement. We'll specify the stage location of those YAML files. The second thing I'm going to do is create a volume stage. This is going to be my persisted volume mount for my containers. So when I create my Jupyter Notebook service, if I edit a notebook in there, I want to save that and be able to come back to it later if my service goes down or it suspends or something like that. Stage-backed volume mounts are what allow us to do that. So when I, save my, new version of my notebook, it's actually going to save in the file system into this stage here. And so we'll look at in the spec YAMLs how we configure those volume mounts. But those are my two stages. One is where my spec YAML files are going to go, and the second is going to be where I volume mount my services. If I look in, use the Database Explorer over here, and I go take a look at my schema, you'll see within the container HOLDB public schema, I have those two specs created. Here, I've also got now my container HOL warehouse, extra small warehouse that I can run queries on. So that is our 00 setup.sql file. And that's all essentially we're doing there as part of the Snowflake environment setup. Once we get through that initial setup, the next thing we want to do is create some container services specific stuff. So within the same step 2, you'll see we also reference the 01 Snowpark container services setup.sql file, which again is part of our source code repo here. You could again run these commands from using the Snowflake extension within VS Code or directly in Snowsight. And so I've already got that notebook or that SQL file copied into a worksheet over here in Snowsight. And I'm going to go ahead and run these statements as well. All right, now while that executes, what am I doing here? The first thing you'll notice is I'm creating a security integration. Why is that? So again, we're going to want users to be able to access our hosted Jupyter Notebook, Jupyter Lab service that we're going to create later via their web browser. To do that, we have to set up a security integration which allows users to sign in using their Snowflake credentials when they go access an endpoint that's exposed by a service. This security integration just supports Snowflake OAuth as the flow to be able to authenticate a user who goes to that public endpoint to access that underlying service. They log in with their credentials, and it's all well and good. So we're going to use the account admin role to set that up. Again, if you don't have account admin role, you need to work with your Snowflake admin to set up these initial integrations. The next thing we're going to do is create our base compute pool. So within Snowpark Container Services, there's sort of 3 core concepts, really 4, I guess, 4 core concepts that make up a service. The first are the base images and the spec YAMLs. So those are the 2 components, like the underlying Docker containers and then the configuration files. The third is then the service, which is constructed from those 2 other things. And the fourth is the compute pool. These are the actual compute pools on which your services are going to run. These are the underlying compute resources. Typically, if you were running a container infrastructure somewhere else, you might be using something like Kubernetes to create these pools. all that sort of stuff. Snowflake abstracts all that complexity away, and through a simple create compute pool statement, we're going to create our base container HOL pool. Now, one of the things to note here as we look at that is this instance family. I mentioned Container Services supports a number of different types of compute infrastructure that you can run your services on. In our case, we're using our standard one instance family, which is basically our base, smallest, CPU-based compute pool instance type. If you go to the Snowpark Container Services documentation and you look into the create compute pool syntax documentation here, you'll notice there's the instance family parameter and then the corresponding sizes that go along with it. So I'm going to be just using our CPU-based extra small, or CPU x64 XS is the instance family. This actually might need an update from one of the old family names, but it looks like that compute pool got created. If we run a show compute pools, yep, you'll see this container HOL pool, standard one instance, which is currently starting. The other thing that I'm going to do here is create an image repository. Why is that? So if I want to create a service using some base Docker images, I need to make those images accessible to Snowflake. Snowpark Container Services as a feature comes with image repository support directly in Snowflake. So you might have image repositories elsewhere that you use, something like an ECR or even just public Docker Hub or something like that. This is a in Snowflake image repository, which is where we're going to push our built images to be able to configure our services. To create that, again, I just use a simple create image repository, give it a name, and then I can run a show image repositories type statement here. And you'll see I have this image repo and this container, the particular database and schema that it's in. Now, one thing I want you to take note of here is this repository URL. We're going to need this here in a little bit when we configure our Snow CLI connection, and then also ultimately can log into my Snowflake image repository and push my corresponding images. So that gets us through the initial Snowflake environment setup. We configure the role and permissions, then we configure some Snowpark Container Services specific objects, specifically our container, our compute pool that we're going to use, and then the image repository where we're going to push our images. Here in the quick start, there's some links to the corresponding documentation that explains all these things in more detail. If you want to take a look at that as well, highly recommend checking that out. But that gets us through step 2, and we're going to move on now to step 3, which is setting up some additional local environment stuff. So the first thing that we're going to do is create a virtual Python environment where we're going to install the Snow CLI. The reason for that is that Snow CLI makes working with both the Docker login to image registry as well as pushing, our spec YAML files and things like that a lot easier. So we're going to create a base Conda virtual environment in order to do that. I'm going to use Conda here. Of course, if you have a preferred virtual environment manager or anything like that, you can of course use that. But the base YAML file for our Conda environment that's included in the code repository here makes doing it with Conda very simple. So you can see really all we're doing is installing some initial dependencies, specifying a Python version. We're going to install Snowpark Python. We're referencing the Snowflake Anaconda channel specifically, and we're giving our environment a name. To do that, we just use a simple conda env create statement. So I'm going to go to my terminal. I've actually already created that virtual environment, so I'm just going to activate it. If you see, run a conda env list, for example, we should be able to see, yep, that Snowpark Container Services HOL already exists. So now I'm just going to run a conda activate Snowpark Container Services HOL. And you can see there, based on my terminal, that we have that virtual environment activated. So once you create it, you're going to run that same conda activate command. It may just take a couple minutes to create the environment as you install some of those initial package dependencies and things like that. And then we're going to activate it. The next thing we're going to do is install Hatch, and that's so that we can do basically a build of, the current build of Snow CLI. So for my terminal, I'm just going to run a pip install Hatch. This should just take a minute to get going. It's going to download or all the various packages and install everything that we need to do that. Cool. And now I'm going to clone and install Snow CLI using Hatch to actually build the Snow CLI. So we're using the most current version, even ones that maybe are not published yet on PyPI or something like that. I generally, again, like to keep everything in a dev directory. So if we go back to dev, I've actually already run go back up to dev, and then cd into our Snow CLI directory. And this is where I've just cloned the Snow CLI repo. So you can see here, there's again a link to a GitHub repository for Snow CLI. Really all we need you to do is clone this repo down to your local machine, or you can of course download the zip folder or whatever it might be into your preferred local location. Now, once I have the Snow CLI repo downloaded, I'm going to cd into that directory in my terminal, and then I'm going to run this hatch build and pip install command here. So I'm already in my Snow CLI directory, so I'm going to run hatch build and pip install. And this is going to just take a few minutes to install the various dependencies. And while that gets going, we'll take a look at where we'll move to next. So Snow CLI is super useful as a command line interface for dealing with anything in Snowflake, but in particular, what we're going to use it to do is create a Snowflake connection that makes it easy to push up our YAMLs and things like that as part of it. So we are going to, once it's finished installing, go through basically the wizard for creating a new connection with Snow CLI to make it easy to connect to our account. Let's see. All right, we're still building here. So while that gets going, let me go ahead and hit pause on recording, and then we'll come back once that build is finished and get started with adding our connection. And I can verify that it worked by just running a which snow, and you can see that that's the snow command installed into my Snowpark Container Services HOL virtual environment. So we're all good there. The build and install worked successfully. Now, Snow CLI, again, makes it helpful. It's an easy way to manage Snowflake objects from your terminal or command line interface. One way that we do that is by creating connections. So this is essentially the configuration of a new connection, which is going to allow me to connect to my Snowflake account from my local terminal. So I'm going to run the Snow connection add, and that's going to basically take us through a wizard to create a new connection. So the name for the connection that we want to use is all outlined here in the instructions, but it's going to be container_HOL. So we'll start there, container_HOL. The Snowflake account name, this is going to be your org-account name. So it's, my org-my account or something like that. The account that I'm using, for example, is in this SFSE North America org. And then it's this container_recording is the name of the account that I'm going to use. So I'm going to do SFSE North America -container_recording. Cool. My username is snowuser. And then I'm going to grab my password from my password manager over here. The role for the connection that we want to set up here is our container user role. Then we're going to use the container warehouse, container database, and the public schema. So we'll go through each of those now. Container user role, container HOL warehouse, container HOL DB, public schema, and then I don't need to configure the rest of these, so I'll just click through. And it creates my new container HOL connection to my configuration file. Now, just to make sure that that all works, we're going to run a Snow connection test where we then specify our container HOL as the connection that we want to test. So copy that over to my terminal, run the test. Awesome. You can see that then we get back the connection name, the status is okay, the account, the user, etc. So we're all good. That means our Snow CLI install worked and our connection was properly configured, which means we can use Snow CLI to do Snowflake stuff. All right. Now, the next thing we're going to do is we're going to test that we can Docker log into the image repository that we created in Snowflake. So if you remember back in step 2, we created this image repo, image repository inside of our Snowflake account. Ultimately, this is where we're going to push the containers that we build up to Snowflake, but we want to make sure that those that our Docker connection and all that sort of stuff is working properly. So first thing I'm going to do is open Docker Desktop or start your local Docker daemon if you haven't already done that. I've already got mine up and running, so we're all good there. And we're going to test that we can successfully log into the image repo. So I mentioned before when we were looking at this that we would need this repository URL, which you can get by running a show image repositories in schema SQL statement. This repository URL is ultimately what we're going to need. Now, the repository URL contains sort of two components. So it has the full URL, which is listed here, which is my org-account.registry, blah, 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 /db/schema/image repo. But it also just has like a host name field. So basically everything up to the database object, that's essentially our repository host name. To test our configuration, we're going to just need that repository host name. So again, if that's basically the full URL up to the database. So I'm going to copy from that query here, just up to .registry.snowflakecomputing.com. Let me go ahead and copy that. Sweet. And now we're going to test our Docker login command. So if you've ever used any remote Docker image repository, you inevitably have used Docker login. Now we're going to test that we can Docker login into that registry that we created in our account. So to do that, I'm just going to run a Docker login, and I'm going to paste that image repo hostname and specify the -u username. So -u snow user, that's my username. Now, one thing I will highlight here is if you remember, my account name has container_recording. In the registry hostname, those underscores get replaced to hyphens. It'll still work just fine, but just something to be aware of. If you put a underscore in here, you'll get a bad connection and all that sort of stuff. So let me run this Docker login statement. It's going to ask me for my Snowflake user password. I'm going to copy that password in, hit enter. And you'll see login succeeded. Awesome. That means that one, our image repository is configured correctly on the Snowflake side, and I can use my Snowflake user and password to log into that registry, which is how I'm going to actually push the containers that we're about to build. So that gets us all the way to step 3. And next we're going to move on to step 4, which is actually building, pushing, and then running our Jupyter service inside of Snowpark Container Services. Moving on to step 4. So the first thing, just like every other sort of development and deployment cycle, we're going to have to build and quickly test our image for our Jupyter service locally. So to do that, we have basically a Docker file and all that sort of stuff that we're going to build and then test out running locally. So if we go into our source code repo here, you'll see in the source directory within our GitHub repo here, there are 2 directories, Jupyter Snowpark and Convert API. This first one that we're going to look at is our Jupyter Snowpark. You'll see there's already a Docker file in there that contains pretty standard Docker build statements. There's certainly nothing unique to Snowflake happening as part of this Docker file, but it's pretty basic stuff. We're going to starting from a base Python 3.9 image. We will run some initial installation and upgrade kind of statements. We're going to pip install some base libraries that we know we need. Most importantly, Jupyter, which is how we actually run Jupyter Notebook from within this container. But also, we're going to install the Snowpark client and some things like that as we go through. We create a user. We're going to copy in a base notebook. We're going to expose port 8888. That's the only kind of important thing because that's how we're going to access the notebook. And then the entry point of our Docker file is just running a simple Jupyter Notebook statement with some configured parameters here, so you don't need a token or a password or something like that to access it. But it's kind of pretty standard Docker stuff, I would say. Nothing super crazy going on here. Nothing really unique to Snowpark Container Services as part of that. So that Docker file is already in the code repo. And so we're going to actually build and test that container. So if first of all, if we, let's see, go back to our terminal, I'm going to go into my directory here, which is where all those things are. I'm going to cd into my source directory and then cd again into my Jupyter Snowpark. All right, sweet. That all looks good. Now I'm going to run a simple Docker build statement. This Docker build statement is the only thing that's really unique to it here is we're specifying that we're building this for Linux or AMD 64, x86 chip architectures. Currently, that's what Snowpark Container Services supports, so we specify that at build time. And I'm going to tag it with just a local repository. So this is kind of a best practice with Docker to tag your local build with like your, first initial last name or something like that. So I'm going to just copy this Docker build statement, take it over to my terminal, and I'm going to change that local repository. Take that placeholder out, and then I'm just going to put cbectold. So I know that this is my local one here. So we have Docker build, blah, blah, blah. Cool. Looks good. Let me go ahead and run that. And that's going to kick off our Docker build process. This is just building that base image, base container in our local environment, installing everything, all that good stuff. Go ahead and hit pause here and skip ahead to our post build and move from there. You'll see here, it took me a little over 90 seconds, almost 2 minutes to run that initial build. Most of that's just installing libraries, all that normal stuff. Depending on your network speeds, it may go faster, it may go slower. But we can go ahead and verify that our build actually worked by just running a Docker image list locally in my terminal. And we should see that, yep, cbectold / Python Jupyter Snowpark latest was just created about a minute ago. Sweet. So that means it worked. We can also go take a look if you like to use Docker Desktop, for example, you can refresh and you'll see that Python Jupyter Snowpark latest was also built a few seconds ago. Whichever if you're familiar with the Docker command line, awesome. We have all the commands that we're using in the quick start here, which is good. But you may also like to use the Docker Desktop interface, but you can use both. So let's go ahead and test it locally and just make sure that our Jupyter notebook, runs and that we can kind of do basic stuff. So to do that, I'm just going to go and run a basic Docker run command. And I'm going to specify my cbectold / Python Jupyter Snowpark latest, which is the exact image tag that's listed here, except with my local repository tag replaced into that placeholder. And that's going to go ahead and spin up my Jupyter Notebook image running locally. Now, if I actually go to my containers now in Docker Desktop, you can see that I have this particular image or this container from my Python Jupyter Snowpark image is up and running, which is cool. And it's got a specific port exposed. So if I go now over into localhost 8888, this should open up my local Jupyter Notebook container. Yeah, sweet. So we got Jupyter up and running. There's a basic base notebook that we put in here. You can open that up and go take a look, and you can see that there's some code. So far, so good. We don't really need to test running these actual Python code or anything like that, but our basic service is up and running, and we're good to go. So I may not want to keep this running. In fact, I don't. So I'm going to go ahead and run Docker stop command as well. Oh, that's not its name. We're going to run Docker stop and just kill that container because I don't need it locally anymore. Now, if I refresh, we should see, yep, okay, cool. So the container spun down. We're all good to go. All right, so we have a base container. It works. Now we need to make it accessible to Snowflake. That's where we use our Snowflake image repository that we created in step 2. So I'm going to need to basically log in to my remote image repo, which we already tested works, so that's good. I'm going to tag my local build with a remote URL tag as well. And then I'm going to push that remote tag as well. So the first thing we do, if we go to our terminal, I'm just going to reload that Docker login statement that we already tested before. So you can see Docker login, and then my image repository hostname, and then my username. That is then going to prompt me for my password, which I will paste over here. Awesome. So my login succeeded. The next step is to run our Docker tag. So go ahead and copy this statement over. What this is doing is taking our local repository build, that tag, and creating a new tag, which is our remote one, which we're then going to push up to Snowflake. So I'm going to remove this local repository. So I don't need a placeholder. And then the other thing that I need is my remote repository URL. So if I go back to, let's go back to Snowsite here, and I'm just going to copy this whole repository URL. Notice this is not just the host name. So we have the host name, but then also the database schema and the image repo here. And I go ahead and run that tag statement. Cool. Now, if I go look in my images in Docker Desktop, you'll see that new tag that I just created is listed here as using that remote URL, all that good stuff. Now, the next thing I'm going to do is just run a simple Docker push statement. So we verified that new tagged image exists. Now I'm just going to run Docker push and specify that new tag that I just created. So Docker push. And then you'll see here we have the full repo image registry URL, and then my Python Jupyter Snowpark dev tag, which is the one I just created. So go ahead and click that off. This is going to take potentially a little bit of time because, again, we're actually uploading our local tagged image, that local container, up to Snowflake now. So depending on how big your container is and your network speeds and things like that, this may take some time. So go ahead and hit pause here while this runs, and we'll rejoin you here after the push command completes. All right, welcome back. As you can see, our Docker push succeeded. Now, can you verify? Right, like the Docker push command seemingly exited successfully. We're all good, but how can we actually double check? Well, fortunately, with Snowpark Container Services, there is a registry list images function that you can call to check and see if your images are in fact up in Snowflake. So I'm going to just pop on over into a SQL worksheet here and switch over to my container user role. And then I'm just going to run that call system registry list images where I pass in the FQDN of my image registry. So that's my database-schema/ registry name. And if I list that, you'll see that sweet Python Jupyter Snowpark image is in fact listed there, which means that our Docker push command completed successfully. Awesome. So that gets, if we go all the way back to the beginning to that development to deployment cycle, that means that our image is now up inside of the image registry. The second thing we need to configure our service is our spec YAML, and that's exactly what we're going to do next. So if you take a look at the instructions here, our next step is to configure and push that spec YAML. There's a copy of a pre-configured spec YAML inside of that source code repo. It's under source, Jupyter Snowpark, jupytersnowpark.yaml. And let's go ahead and open that up and take a look at the contents. The first thing that we need to do is, one, replace that placeholder with our registry host name. So if you remember our repository host name, we're just going to go ahead and copy that one more time. And you'll see here in line 4, the image, there's this repository host name that we just want to replace there with our our image registry URL, the host name for that. Now let's take a look at what's actually contained inside of this YAML file. So first of all, once we update that, let's take a look. So there's a lot of different things that you can include in a spec YAML file. If you go into, again, the documentations, or the Snowpark Container Services documentation here, there's a full YAML syntax reference doc that explains like all of the optional arguments that you might include as part of your YAML file. But there's really some like core things that we need to have. The first is, what are each of the containers that we're actually going to run inside of this service? In this case, I'm just running one container. It's my Jupyter container, but an individual service might actually be comprised of multiple containers for like a full stack application, as an example. So you can list multiple containers. In my case, I'm just going to have one. That line 4 is one of the critical elements that says, okay, what image in my Snowflake image registry should I use for this particular container? And so all we're doing here is passing in that image tag that we pushed up, which has our registry hostname, db/schema/registry, and then our Python Jupyter Snowpark dev tag. That basically says, for this particular container in my service, run this image. Now I'm configuring a couple of other things as part of this. One, I'm going to configure a volume mount. I mentioned this previously so that when we save changes in our Jupyter notebooks, they're persisted across service runs. So I'm going to mount, in this particular case, home/Jupyter is going to be my Jupyter Home volume mount. And then below, I'm going to mount Jupyter Home to this stage location here, which is at volume/Jupyter Snowpark. If you remember back in the initial setup, we created this volume stage, which if we just take a quick look at our Snowflake Database Explorer, we have in public this volumes stage here that's been created. What this is going to do is basically say everything that's persisted or saved in home/Jupyter is actually going to be persisted in the volume stage/Jupyter Snowpark. So that's what that volume configuration is. The next thing we're going to do is, remember, Jupyter exposes port 8888 as the URL to be able to actually log into the Jupyter notebook instance. In our local machine, that was just localhost 8888. But we need to expose port 8888 as a public endpoint in Snowflake that I can go to and then log in as a user to be able to access my Jupyter notebook. So we just are specifying this Jupyter Snowpark port that's going to be exposed, or endpoint that's going to be exposed. It's going to be exposing port 8888. And in particular, I want this to specify a public endpoint, meaning that that's a URL that I can access from my web browser. Now it's not public in that anyone can access it. I'm still going to have to log in as a Snowflake user to get into it, but it's going to make that URL accessible to me so I can log into my Jupyter Notebook service. Okay, so that's the basics. Remember to, in step 4 here, replace that placeholder with your repository host name, and that's a full, complete service YAML. Now, on top of making the image accessible in our Snowflake account, we also now need to make that YAML file accessible in Snowflake. And to do that, we're going to use the Snow CLI to push that YAML file up to our specs stage here. So if I go back over into my terminal here and I run from inside of that Jupyter Snowpark directory, I'm going to run a snow object stage copy, where I'm going to copy that file up to the specs stage using my container HOL connection. Let's see. Awesome. It succeeded. Status uploaded. Everything looks good. If we want to double check, we could actually go back over into the Data Explorer here in Snowflake. Let me switch to my container user role. And if I look at the container HOLDB, and then I look at my specs stage, let me go ahead and enable directory tables, select my warehouse, and you can see that my Jupyter Snowpark YAML file is now here in Snowflake, just published about 30 seconds ago. All right. Back to our instructions. You could, of course, list the files in that stage as well, just how you would normally list stage files. That gets us to everything we need to now run this service is accessible in Snowflake. The image has been pushed. We have a YAML that's configured to create our service. Now we need to actually create and test the service. Okay, so let's go ahead and create and test that service. To do that, we use just a simple SQL statement. So we have in our source code repo, again, the 02 Jupyter service.sql, which basically has all of the different statements and everything that we need to create our service. Again, I've gone ahead and uploaded that worksheet into Snowsight here, and I'm going to show you running through it there. So the first thing is we're going to set up our context, database, schema, role, etc. And then to create our service, we just have this simple create service statement. Now you can see there's a couple of things here. One, we're going to specify the service name. Two, we're going to specify which compute pool it's in, which if you remember from a previous step, we created this extra small CPU-based compute pool. So we specify that that's the compute pool where we need it to run. And then we specify the location of the spec YAML for this service. So in this case, it's from our spec stage, and the specific file is that jupytersnowpark.yaml. Let me go ahead and run that statement. And we get a service successfully created response back. Now, it does take a little bit of time to provision the services to the resource. So there are some handy functions to help understand what's the status of my service, what do the logs look like, etc. This get service status, you can see here, tells us, is the service up and running? In our case, it's still pending. It's waiting to start, which is fine. We just ran the create statement. But you can also see other things like what's the name of the container, what's the image location that it came from, if there were any restarts associated with it, some things like that. Now, if I refresh that, should just, still waiting to start. So we should see it come back up. The second function that we have is the get service logs. So once our service is up and running, it produces logs just like how any application would. Snowpark Container Services automatically captures those logs and then makes them accessible through this service function as well as event tables. So now check on that status. Awesome. We see that our service now is up and running. Because it's running, I can now get its logs. Cool. And you see this actual whole log stack that came out here. And if we take a closer look, let's see, we might be able to see, that the Jupyter server is now up and running on port 8888. All good. So far so good, but I can't really see or do anything. How do I log in? How do I access that Jupyter host? Well, before when we were running it locally, you would use localhost 8888 to access Jupyter. But we're now running it inside of Snowflake. So our Jupyter Notebook is running inside of Snowflake. How do I go actually get access to it? If you remember from the YAML file, if we take one more look back at that, we configured this Jupyter Snowpark endpoint as a public endpoint. So we can now show the endpoints inside of that service, and you'll see that Jupyter Snowpark endpoint is exposing port 8888, and it's got this field for an ingress URL, but the provisioning is still in progress. So once the service gets up and running, basically what this is going to do is generate a random URL string that we can then use in our browser to go log in to that exposed port. And so if we check one more time, there we go. The URL is populated. So you see the URL takes the form of this random string, and then it does your organization account.snowflakecomputing.app. Let me go ahead and copy that ingress URL. If you take a look back at the instructions here, you'll see that once we're in a running service, you can run show endpoints, and then we'll copy that URL, which we got from that show endpoints statement. Now, let me go ahead and put that into my browser, and it should ask me to log in as my Snowflake user. So this is using that security integration for auth that we created at the very, very beginning of the lab. I'm going to just log in using my Snow user username and password. And now notice that our Jupyter Notebook interface now pulls up. Give it just a minute there. Awesome. So we actually have Jupyter running, but if you look at the URL, we're running on that snowflakecomputing.app location. So we have Jupyter running inside of Snowflake, and I can access it through my web browser from my local laptop or wherever else I might be. Pretty cool. Now we need to actually get started with like writing some code in Jupyter, maybe. So to do that, we're going to upload and modify a Jupyter notebook. So if you remember right, we mounted that volume/Jupyter Snowpark location to our home directory inside of the container. If we go take a look again inside of Snowsight at that stage location, so if we go to public, stages, volumes, we'll see that there are no files here quite yet. But if I, let me just double check actually real fast. Volumes. There we go. With a quick refresh, we see that our Jupyter Snowpark folder exists now. If we go in there, there are some kind of local hidden files. Those are basically the files from our home/Jupyter directory inside of our running service. So now I want to upload a notebook to actually edit it. There's a couple different ways I can do that. One, from my Jupyter service, I can just go to upload. It's going to come up and it's going to prompt me. And I'm going to go to, if we go inside of your clone of the code repository and go into source, Jupyter Snowpark, there's this sample notebook.ipynb. I'm going to go ahead and just open that and upload that into my running Jupyter in Snowpark container services. Cool. Now I can click into that notebook and you can see that it's a normal notebook. It's just like if you were running this anywhere else. There's a base notebook. It's got some example markdown, and then some sample code and some things like that. We'll look at this more closely in a minute. But because I have uploaded that notebook into my service, just into my home directory here, what's over in that volume stage now? If I refresh, you'll see that my sample notebook actually exists inside of this stage, which means it was just modified a few seconds ago, which means that if I also maybe edit my my notebook here, maybe, hey, this is a new markdown cell. And go ahead and save my notebook with those changes. Now, if I go back and refresh, we'll see that that file was just modified 5 seconds ago. So all of my changes that I'm making in my service here are being persisted in that stage, which means that if I log out and come back, they'll be there. But also, if my service gets suspended or I turn it off or bring it down or something and then bring it back up, it'll remount these notebooks into that environment so that they're there even after a service restart, which is pretty cool, pretty critical, especially for these kind of developer tooling sorts of apps that you might run here. But also if you just need to make certain files accessible and persisted over time to your services. It's an awesome way to do that. Now, of course, I could also, if I wanted to upload a new file directly here, if I add the file into my stage, it would then show up over here in my home directory. There's a number of different ways. You could also use Snow CLI to actually push files up to the up to that stage or whatever it is. It doesn't really matter how you go about doing it. In either case, those files are going to be persisted using that stage. Pretty cool. So we now have a working notebook up in our Snowflake account using a Snowpark container service. I can test that it actually works by running some sample code cells. So Snowpark's services give you a session token inside the service that you can use to then connect back to Snowflake to run queries. So, right, if I have a Jupyter notebook, maybe I want to use Snowpark to execute queries and then pull data into my notebook, maybe, or ever manipulate it or whatever. I can create a session using this normal Snowpark syntax using just that token, and that actually gets me to a warehouse where I can now execute queries against my Snowflake account to process data, pull in data into my notebook, whatever it might be, depending on kind of the workload that I'm building in this environment here. But pretty cool. We can now connect, run those queries, and importantly, nothing's leaving the Snowflake boundary. This is all happening over the virtual network between my service and your kind of base Snowflake warehouse compute, and nothing's leaving out over the public internet or anything like that. So pretty awesome. That means we've got a fully running Jupyter Notebook service This is a long-running service. If you remember, think back to the beginning. It's going to be up. Maybe it's up 24/7. Maybe it suspends at certain times or whatever. But this is something, something I go log into in my web browser and I interact with. But what about the next kind of piece of this? What about a REST API or something like that? That's going to be step 5. Okay, so step 5 is going to be our next service. So let's go ahead and click into step 5 here. This is basically going to be a Python or REST API that runs a simple temperature conversion. So it's going to take in, like a Fahrenheit temperature as a post request, and then respond back with a Celsius temperature. Really trivial and basic. But in theory, it's just a generic REST API service. So you can kind of do whatever you might do within that REST API service. The flow for this step 5 is almost exactly the same up until kind of the very, very end, where we create a service function. But the processes for building and tagging and pushing the underlying, images, YAMLs, etc. for the service is just like our Jupyter Notebook one. So we're going to move pretty quickly through this one. We'll take a quick look at all the different things that are going on here. But it's generally going to be kind of the same sort of format as before. So in our code repository, next to the Jupyter Snowpark source folder, we have a Convert API folder, which includes a Docker file. Same as before, this Docker file is our basic kind of commands for what is this container going to be doing. Here we're using a base 3.11 Python image. We install some requirements that are specified in this requirements.txt file. And then we just run our Flask REST API on port 9090. And our Flask API is defined in this convert app.py file. It's very basic. It's got a single convert endpoint where it does a Celsius to Fahrenheit conversion, like I mentioned before, takes in data, does the conversion, responds back with the converted data. Pretty trivial. And then it uses Flask to basically run that API on that endpoint. But that's really it, right? We have a simple Flask API, which you can look into more detail into the convert app.py file to see what it's doing. And then we have a Docker file that just runs that Python file on port 9090. That's basically it. Nothing too crazy. So if we go back to the instructions, we need to run a Docker build, just like before. So we're going to cd into that convert API folder first. And then I'm going to go ahead and copy this Docker build command. So cd up a level, and then cd into convert API. Cool. And then I'm just going to copy that Docker build statement. And again, this is just my local build. So I'm going to give it that local repository tag, cvectold. Awesome. And then kick off this statement. And again, because we're installing some requirements and things like that, this might take a couple minutes. We're not installing a whole lot here, so this should be pretty quick. It's going to run just that base pip install. C. Awesome. Super fast. 10 seconds. So this image is a lot smaller compared to the Jupyter one we built before. So it didn't take nearly as long. Now, if I want to double check that that image got created successfully again, I can run a Docker image list. And we see up here that convert API was created 16 seconds ago. Cool. And now I just want to test it, right? So again, we're going to use a Docker run to test it. I'm exposing port 9090 in this case because that's the port that my REST API is running on. So go ahead and copy over this Docker run statement and then change that local repository to, again, be the tag that I used. So cvectold. And it's going to spin it up. And then we can run a Docker ps command just to check. Yep, that container is in fact up and running, as you can see here, using that Flask run statement. And it's exposing port 9090. Now, if I want to test that it actually works and does my Celsius to Fahrenheit conversion, I can use something like curl to just do a simple test to pass in some input data, which are my Celsius temperatures, and I would expect to get back Fahrenheit temperatures. And I'm posting that to localhost 9090 / that convert endpoint. So I just go over to terminal, copy that curl command, and and you see when I run it, it actually spits back this exact response of 53.6, 66.2. etc., which are the Fahrenheit converted temperatures of the input Celsius temperatures that I created. So the local test is working good. We have our API, it's up and running. It's converting temperatures where it takes input data looking like this, which are basically number of records and then the data. So we have record 0, record 1, etc. And then it responds back with the corresponding conversions. All good. I'm going to go ahead and stop that local one because I don't need to run it. We're going to run it inside of Snowflake instead. So go ahead and stop it locally. And it should spin down here. There we go. And I can check if I just run another Docker PS command, I can double check that, yep, it's exited. And it's no longer running. Cool. So I need to do my Docker login and my Docker tags, just like before. So if I just go back and go ahead and log in, using a Docker login statement, it's again going to ask for my password. Where is my password? There we go. And should get a login succeeded. Cool. Now I next need to run our Docker tag, remember, which is our Docker tag where we convert our local repository tag into our remote repository tag. So I will first change this Docker tag here. Let me get that repository URL one more time. Here. Perfect. Grab that repository URL and then replace that in here. All right. And that's going to create my tag. If I go again, check in Docker Desktop in my images, I can now see that convert API dev remote tag is there. And the next thing I just need to do is our Docker push statement. So if I do Docker push and then specify that remote tag that I just created, copied the wrong thing. You just want the remote tag here. So we do Docker push and then specify the remote tag. And we'll see that push happens here. Again, this should be pretty quick. It's a small image, so even with my relatively slow network speeds, this shouldn't take too long to push everything up. And in fact, notice this, it's actually reusing some layers from my other service that already exist up there. So there's some shared layers between these two base containers. So it's just mounting those from the existing one as opposed to pushing them from scratch, which is pretty awesome. So we should be getting a confirmation here momentarily. Pushed, mounted. Awesome. Successfully completed. And if you remember, we checked before that those existed by running a list images command. And you should see now, yep, we have that convert API image also listed in our image repository and alongside of our Python Jupyter Snowpark one. Cool. So what's next? We need to configure and push the spec YAML, just like before. In this case, if we go into our source code again, within the convert API, we have a convert API.yaml. We need to copy that same host name that we copied in for our Jupyter one into line 4 here. This is even a more basic spec YAML here because all we have is the one API running that image, exposing port 9090. And that's it. There's no volume mounting in this case or anything like that. We're just going to expose this REST API as a public port 9090 endpoint. So I've got that YAML saved with that repository hostname replaced. And now I just need to run that Snow CLI statement again to copy my YAML file up into my Snowflake account. And that's, again, a Snow object stage copy where I specify convert API.yaml. I want to upload it to the spec stage. I go ahead and run that. We should get a confirmation here momentarily. Yep, uploaded. Cool. Can double check by, again, going back into my Snowflake account and going over to data, go into that stage, and we should see then, if I refresh, yep, our Convert API YAML is now here and was just uploaded about 30 seconds ago. So far, so good. Now, we also have, similar to our Jupyter service, there is a O3 REST service.sql, which has all the commands for creating our REST API service, which you can copy over into a Snowflake worksheet or run using the Snowflake VS Code extension. I've already got those copied over into a worksheet here. Oh, they're not copied, actually. Let me go ahead and just copy everything here. Awesome. And same as before, we set up context for the database schema, etc., that we're going to use. And now we're going to create our service itself. Just like before, we do that using a very basic create service statement where we specify the compute pool. We're going to use the same compute pool actually as our Jupyter service, and then we specify the file location of the spec for it. Go ahead and run create service. Service successfully created. Awesome. We can get our service status. You can see it's still pending just like before. But also, if I wanted to do a show services statement, we'd see that we now have both the Jupyter Snowpark service as well as our Convert API are both configured services. Double check on the service status. We can see it is up and running. Awesome. Now, same as before, I can access the service logs, and you can see the Flask logs, for example, that get generated, that the service is now running on port 9090, all that kind of stuff. Now, unlike our Jupyter service, this is just a REST API. This doesn't have some, the front end that we're going to go log into in our web browser. We just want to expose this REST API as a function. And to do that, Snowpark Container Services has service functions to support exactly that. So to show how we use the service function, first I'm going to create some sample data and just put it into like a dummy table. So I'm going to create this table weather that's got some, for locations and dates, it's got a Celsius temperature and a Fahrenheit temperature, but you notice that all of the Fahrenheit temperatures are missing. Let me go ahead and insert this sample data into that table. Now, if I do a, select star from weather, limit 3, we have example records here. Dates, locations, temperature Celsius with null values for temperature Fahrenheit. Well, our Convert API allows us to convert from Celsius to Fahrenheit. Again, it's a trivial example, but it's a REST API running in a containerized service on Snowflake that does that conversion. Because we've exposed it as a REST API, we can support creating a service function. So just like how we create user-defined functions in Snowflake, you can create service functions where the functions call out to those REST APIs running as services. In this case, I'm going to create a function called convert UDF, where it takes an input, which is our float, which is the Celsius temperature, and then returns a float. And notice that I'm referencing here the Convert API service, which is the name of the service that we created up above, and the Convert API endpoint, which is the endpoint that we configured in our service YAML here. Now, when I create this function referencing those service endpoints, what that's going to actually do is now when I call convert UDF in a select statement, for example, it's going to send my input data, my input to that function, to my REST API and get the response as the result. So if I select here, you'll see the converted result comes back. Now, how do I know this actually used the REST API? Well, one, if I go take a look at the service logs now and scroll down, we should see at the bottom of the logs here that there was a post request that came in at the time that I requested it. If you don't believe me, let's see. We can run it one more time. We might actually just use the query result cache here, but we should see now, if I go take a look at the logs, we should see a second log statement also pop up. Yep, so a second request just came in as well. So we're actually making post, Snowflake is making post requests to our service REST API, running the conversion function, and then returning the results. So I can now update our weather table to call that convert UDF and set the temp Fahrenheit column to the function's output. So if I run this update statement, you'll see that there are 10 rows updated. Now when I look at my weather table, that temperature Fahrenheit is successfully populated. Now, you're probably not going to use Snowpark Container Services to do Celsius to Fahrenheit conversion. But what you can do is run things like GPU-accelerated machine learning models behind these REST endpoints to create predictions that are saved into tables, just like using this exact same pattern, but where now your function, instead of calling a temperature conversion API, it's calling a model REST endpoint or something like that. So you could start to incorporate custom processing and functionality directly into data pipelines through both the usage of Snowpark Container Services and the corresponding service functions that integrate really, really nicely into all the existing kind of pipeline management, table creation type stuff that you're doing in Snowflake today. So that gets us up to creating and testing our service function. One thing that is also cool is, if you remember, we in our Snowpark or our Jupyter service, we created a Snowpark session that connected back into Snowflake. What if I wanted to call that REST API using using that service function, but from a Snowpark session in my notebook here? I can run exactly that. So I create a Snowpark data frame that references my weather table. Now I want to actually add a new column, which is tempf Snowpark, just to delineate from the tempf column that we already have, where I can call my convert UDF on the temperature Celsius field. Now, if I run this cell, we missed an import statement. Import snowflake.snowpark.functions as f, and try again. And you see here we have this tempf Snowpark column now, which again is the same output as our previous calls, but we're using the Snowpark data frame API from a Jupyter notebook running inside of Snowflake to call out to another service that's also running inside of Snowflake that's doing this temperature conversion using a Python REST API. But again, that REST API could be doing anything, right? Any sort of custom processing calculation, whatever it might be, that you can start to reference in this way. Of course, now too, if I save my notebook and I come back to it tomorrow, my new code's going to be persisted here and all that sort of stuff because we have that stage back volume mount. That gets us through the bulk of our quick start here. Now, there's a couple more steps involved that just walk through, here are all the different ways that you can manage your services and how you get service status. And there's some links to documentations about all these various functions, how you get the logs, all those sorts of different things. These are just helpful resources now that you have services up and running to be able to interact with them and see how they're doing, check service status, check the logs, all those different kinds of things. The last thing we're going to do is just suspend our services so that they are no longer using their compute pool resources. So just like how virtual warehouses bill based on per second utilization, Snowpark Container Services bill based on per second compute pool utilization. So if I have a compute pool that is up and active, it is using Snowflake credits per second, similar to how a Snowpark or how a normal virtual warehouse does. The exact rate depends on the type of instance that compute pool supports, but makes it so just like warehouses, if you're not using them, it's a best practice to just go ahead and suspend them as well. So I'm going to go ahead and go into my teardown here, and I'm just going to alter the compute pool and by stopping all the services, which we can do stop all. Now that the service is stopped, if I go try to reload my Jupyter thing, for example, my Jupyter service, even though it's going to ask me to initially log in, which I'll log in as Snow user, it's not actually going to work because the service is suspended. It's no longer up and running. That's simple. We just kind of turn it down. And then I'm going to just go ahead and suspend the compute pool also so that it's no longer incurring any charges or anything like that. If you want to go through a full teardown, this script also includes like your drop service, drop compute pool, drop database, etc. statements where you can drop everything to kind of clean back up your dev environment. But I really just want to highlight suspending the services and the compute pools as sort of the final steps to clean everything up so we're not incurring any unnecessary charges or anything like that. Now, importantly, the compute pool also can have auto suspend configured. So if there are no active services, eventually the compute pool will also suspend itself. But rather than waiting for the auto suspend, you can, of course, manually suspend it using an alter statement, as you see here. And that takes us to the end. Here in the conclusion, there's a link to a lot of related resources, documentation, some good blog posts, and things like that to assist with you as you continue building with Snowpark Container Services. Thanks so much for following along as we walked through the intro to Snowpark Container Services Quick Start. You can now get started and try this yourself in your Snowflake account, as long as you're in one of the supported public preview AWS regions. If you're not in one of those regions, but you still want to get started and try out Snowpark Container Services for yourself, reach out to your Snowflake account representatives, and we can look at getting you private preview access into one of the regions that's not yet in public preview. But of course, we're always expanding the regions that are included in that public preview, so stay tuned. Your region may be on the list very, very shortly, at which point you can get started and try all of this out yourself. There's a bunch of links to documentation and resources in the description below. And as always, please like this video and subscribe to our channel to stay updated on all the new things that are going to continue coming out on Snowflake over the next year and even beyond. So thanks so much for following along, and I can't wait to see what you all build. Hopefully this year at Summit, we'll get to see some really cool examples of applications running in Snowpark Container Services. Cheers.